My name is Jacques. I'm the co-founder and CEO of Hive. We are a UK-based robotics and industrial automation startup company. So for the last 2.5 years, we have been working in parallel with the companies on the screen. What we've experienced from our time in doing that is that automation today is really, really good at repeating high processes at high volume, doing the same thing time and time again. Let's take GSK, GlaxoSmithKline, as an example. GlaxoSmithKline make toothpaste. Each of their automation systems is processing the same toothpaste tub, box, and location time and time again. But when we look at GSK's contract manufacturing business, we see that the volumes are smaller. We see they need to change and flex depending on the customers that they're working with at that given time. So what we believe is that automation is not good at supporting low volume, seasonal requirements because it's not flexible. So let's look at this example. This is a very standard palletizing robot cell doing the same picking location, same box, and repeating that action time and time again. What you can see from the diagram is that actually within this system, it's a combination of many different technologies, all of which need to come together through the work of what a system integration company can offer. Now, when the system integrator deploys the system, what we believe is that actually what we get at the end of this is a very fixed system. So we don't have something that's flexible to cater to the varying needs of a changing shop floor environment. We also see there's a lot of technical risks each time every one of these systems is deployed, and that causes a lot of dependency on the system integration company. All equals cost. But what if it doesn't need to be like this? What if we could create one single robotic system that could carry out many different tasks, that the same robot can carry any different box, weight, size, material, and imagine we could actually have a library of different gripping solutions that which change to carry out a very different requirement for that system. Imagine if we could actually change the robot using the same infrastructure, but actually put a larger robot in to carry out a different task, all under the same common infrastructure. Let's take that concept one step further. We want to roll this out now to an entire production line. So not only do we apply this to robotics, but all of the manufacturing applications, systems, and technologies are all operating under one common library. And that, ladies and gentlemen, is what we're building today. One single pre-configured library across robotics and industrial automation systems. The team behind this is a team of 7 engineers from system integration companies and software, all of whom have worked on projects for the companies listed below. We're backed today by super angel investor Jan Koeman, who's the former CEO of JP Morgan Credit, Professor Peter Hoffman, who's the ex-TTO of KUKA, Festo, and Krones, and the former head of transformation at Google, Steve Griffiths. And we've raised 1.2 million to date. We're have rolled out 3 pilot projects over the last 6 months, and we're now in a position where we're looking to scale that into a production-ready solution in line with 4 million investment by the end of 2023. That will put us on a course to our Series A next milestone, where we've acquired potentially up to 15 customers. Thank you for your time. I welcome any questions.
How complex it is for you to scale up to different applications, I mean, time to market. So I got the concept of libraries, but each specific industrial application requires, I believe, specific development. How does it work?
Yeah, so we are applying function block codes through PLCs, which connects to our IoT infrastructure. Allow me to quickly get a diagram up so I can help create some visualization for you. I'm not sure if you can see this, but I will explain it anyway. So we run function blocks through our cloud infrastructure, which are deployed into many different devices. That gives us a large scope of capability. So really it's around controlling the robot kinematics through our PLC code, and all of that is governed by our edge device. So our edge device is enabling our customers to use bits of code as and when they need them. So when you change the robot from one application to another, we can flex, enabling only the code to be operated that's needed at that given point. And from a revenue perspective as well, we only charge for the utility of the code that's being used for that particular application. We're running it from a PLC, so that means that we can have enough control over lots of different subsystems, which gives us the breadth that we can apply it to a number of different applications. This is how we're handling that scalability challenge across different industrial applications.
Thank you very much. Do we have another question?
Perhaps on a similar perspective, I understand that your solution is mostly about the software. How much do you rely on the different robots that you integrate with, and how do you handle the fact of scaling to numerous robots, different than hardwares?
Yeah, so we are driving kinematics. We have a process where we have to map to different robot controllers. We're not replacing the robot controllers, we're working with them. So there is an integration. If a customer says to us, well, we have a specification for an ABB robot, and let's say we don't support that ABB robot today, then we take that internal requirement, specification, we apply our code, which typically takes about 1 to 2 weeks, to that particular specified robot, and then that is on the library, so we can use that again moving forward. In terms of other hardware devices, one of the key features of our system is that we are underpinned by a graph database. I don't know if I can share this very quickly and explain this to people on the screen, but if not, I will walk you through it. So we are collecting data from lots of different machine specifications, okay? So we take the documents from all the different machinery and OEM providers, we put that into a relationship database, what's called a graph database, and then we standardize that in relation to our ontology and our overall smart work. And what that allows us to do then, and that's what this image is showing, this orange node is a piece of data. And then we are building a CAD model, a standardized CAD template, which connects that to then all the gripping solutions here. So what the orange robot is showing, a FANUC robot, and then we have different gripping solutions with these other orange nodes. And then these BotHive connectors are small CAD models that we have designed using artificial intelligence, where we've applied the numbers from the specification documents into our templates. Those templates self-generate, and then we enable that connectivity through a mechanical perspective to all these different other products. So a little bit complicated, but that's how we're applying data to really enable us to operate on mechanical connectivity across a wide range of different technologies.